The last interest rate related contract that will introduce in this section is the forward rate agreement. Forward rate agreements are cash-settled forward contracts between two parties with a payoff linked to the future value of a reference interest rate. The interest is based on a hypothetical deposit and paid at a predetermined future date. The long and short positions agree to exchange the difference between a pre-agreed fixed rate and the reference interest rate prevailing on some future date. If the reference rate is above the fixed rate, the long position receives the difference at the expiry of the forward rate agreement. Otherwise, the short position receives the difference. Thus, one takes up the long position in the forward rate agreement to hedge against the rate rise, and the short position to hedge against the rate fall. The forward rate agreement market is primarily an interbank market and represents the over-the-counter equivalent of the exchange-traded futures contracts on short-term rates. Suppose X represents the annualized fixed rate and Y represents the actual annualized reference rate prevailing at the settlement day T. Both rates are based on the actual over 360 convention, and they are interest rates relevant for a deposit with notional principal N and a deposit period of M days after the settlement day T. Here's the timeline to illustrate how the forward rate agreement works. The contract is signed on day 0 and expires on the settlement day T, where the reference rate reveals. The interest is then calculated based on the hypothetical deposit for a period of M days from the settlement day T. The net cash payment to the long position of the forward rate agreement at the end of the deposit period, that is, day T plus M, can be calculated as follows. Note that the interest is calculated based on the actual over 360 convention. Generally, the payment due at T plus M is discounted back to the settlement day T using the reference rate Y for the discounting. Thus, the net cash payment to the long position at the settlement day T is equal to the following. The interest at the end of the M-day deposit period times the corresponding discount factor. The quote convention for the forward rate agreement identifies the point in time when the deposit period begins and ends. Thus, a forward rate agreement covering the period starting 1 month from now and ending 4 months from now are referred to as a 1/4 contract. The reference rate is the 3-month LIBOR. Similarly, forward rate agreements on the 6-month LIBOR for settlements 1 month forward are called 1/7 contracts. On any given day, forward rates are available for both 3 and 6 month LIBORs, 1 month, 2 months, up to 6 months forward. For example, a bank will, in 3 months, lend $1 million to a client for 6 months. The bank uses forward rate agreements to lock in the future funding cost for this loan. It asks for a quote on a 3/9 forward rate agreement and gets 5.5%. It then offers a fixed rate of 6% to the client and takes up the long position in a 3/9 forward rate agreement for $1 million. Suppose that the 6-month LIBOR is 6.2% 3 months from now, and that there are 182 days in the 6-month period. Can you determine the profit or loss for the bank, both in the long and forward rate agreement? Since the bank offers its client a fixed rate of 6%, and the actual 6-month LIBOR 3 months later turns out to be 6.2%, the bank has a loss of 0.2% on this $1 million loan, which equals $1,011.11 for a period of 182 days. On the other hand, the bank also holds a long position of a forward rate agreement with the fixed rate at 5.5%, therefore, from which it has a gain of 0.7%. This is equivalent to a cash amount of $3,538.89 for the 6-month period. Then, the net profit that the bank can get from this loan is 0.2528%. Annualizing on actual over 360 basis, we obtain a return rate of 0.5%. Now let's talk about how to price a forward rate agreement, which amounts to deriving the fixed rate, that is, the forward rate for the deposit period. Let's assume that there's no default risk on the part of the forward rate agreement writer. At any given time t, the forward rate for the forward time period from capital T to capital T plus M can be calculated using the following formula, where DT1 T2 denotes the discount factor for the period from T1 to T2, and it is an annualized rate on an actual over 360 basis. At time 0, the value for the long position of a forward rate agreement for the period from day T to day T plus M can be calculated from the difference between the expectation of the reference rate Y and the fixed rate X times the notional principal N times the period length on an actual over 360 basis, and then discount to time 0. Thus, to make the forward rate agreement zero-valued at time 0, we set the fixed rate X equal to the expectation of Y, which is the time 0 forward rate from T to T plus M. At time small t, after the inception of the forward rate agreement, the value for the long position of the contract for the period from capital T to capital T plus M is calculated from the difference between the time small t forward rate from capital T to capital T plus M and the fixed rate X times the notional principal N times the period length, and then discount to time small t. Substituting the forward rate formula to the above expression, with some algebraic manipulation, we get the following alternative formula. And from this expression, we can see that the value of the forward rate agreement changes in tandem with changes in the spot LIBORs for the maturities at capital T and capital T plus M. In this lesson, we have learned the forward rate agreement and its valuation, and that is the end of the section on interest rate contracts. Next lesson, we will talk about the currency contracts.